The requirement for a load calculation from an architect for a multi-dwelling building is likely a local requirement imposed by the city or county. Different jurisdictions have different regulations regarding electrical renovations and permitting, so it is important to check with the local building department for specific requirements. The National Electrical Code (NEC) does not explicitly require a load calculation from an architect for multi-dwelling buildings. However, Article 220.87 of the NEC does state that the total load of all the lighting and receptacle outlets on each branch circuit shall not exceed the rating of the circuit. In general, load calculations are not typically required for residential renovations that involve the replacement of electrical panels and circuits. However, some jurisdictions may require load calculations for larger projects or for projects that involve significant changes to the electrical system. Here are some recommendations. Firstly, contact the building department in your jurisdiction to confirm their specific requirements for electrical renovations in multi-dwelling buildings. Secondly, if a load calculation is required, consider hiring an architect to perform the calculation. Architects are trained in electrical design and can ensure that the calculation is accurate and meets code requirements. Thirdly, when applying for the permit, be sure to provide any documentation that the inspector requires, such as a load calculation or plans from an architect. It is always advisable to comply with all local building codes and regulations to ensure the safety and code compliance of the renovation project. Electrical load calculations are essential for ensuring the safe and efficient operation of electrical systems. They involve determining the total electrical demand of a building or specific circuits to prevent overloads and potential hazards. Firstly, understand the purpose of load calculations, which is primarily to determine the size of the electrical service, feeders, and branch circuits required to safely and adequately supply the electrical needs of a building or area. This prevents overloading the electrical system, which can lead to overheating, fire hazards, and equipment damage. Secondly, you must be familiar with the National Electrical Code (NEC), which provides detailed guidelines and formulas for performing load calculations. Local codes may also have additional requirements or amendments to the NEC. Thirdly, the first step in performing a load calculation is to identify all the loads that will be connected to the electrical system. Loads can be categorized as lighting, receptacles, appliances, heating, ventilation, and air conditioning, HVAC, and motors. For lighting loads, calculate the total square footage of the area to be lit and use the NEC prescribed watts per square foot values for different types of occupancies. For example, a dwelling unit typically requires 3 watts per square foot for general lighting. For receptacle loads, use the NEC requirements for general purpose receptacles, which typically require 180 volt amps per outlet. In dwelling units, small appliance circuits and laundry circuits must be included, each rated at 1500 volt amps. For appliances, use the nameplate rating of each appliance in volt amps or watts. If the appliance is used continuously for 3 hours or more, multiply the load by 125% as required by the NEC. For HVAC systems, use the nameplate ratings of the air conditioner, heat pump, or electric heating units. Include the volt amps rating of the compressor, fans, and any auxiliary heating elements. For motors, use the horsepower rating to determine the full load current from the NEC tables. Multiply the full load current by 125% for the largest motor in the group if it operates intermittently or is part of a continuous duty application. After identifying and calculating all the individual loads, apply any applicable demand factors. Demand factors are reduction percentages that account for the fact that not all loads will be operating at their maximum capacity simultaneously. The NEC provides demand factors for various types of occupancies and loads. For dwelling units, demand factors can be applied to the general lighting and receptacle loads based on the total square footage of the dwelling. For example, the first 3000 volt amps of the general lighting and receptacle load are taken at 100%, while the remainder can be reduced based on the NEC tables. For electric ranges and cooking appliances, the NEC provides specific demand factors based on the number and rating of the appliances. These demand factors can significantly reduce the calculated load. After applying all applicable demand factors, sum up the remaining loads to determine the total calculated load. This total load is used to determine the required size of the electrical service, feeders, and branch circuits. To determine the service size, divide the total calculated load in volt-amps by the system voltage to obtain the total current in amps. For example, if the total calculated load is 24,000 volt-amps and the system voltage is 240 volts, the total current is 100 amps. Select the appropriate size of the service entrance conductors and overcurrent protection based on the calculated current. Consult the NEC tables for conductor ampacity and overcurrent protection requirements. Ensure that the selected conductors and overcurrent protection devices are rated to handle the calculated load safely. To determine the feeder size for individual circuits or subpanels, follow a similar process. Calculate the total load connected to the feeder, apply any applicable demand factors, and select the appropriate size of conductors and overcurrent protection devices. For branch circuits, ensure that the conductor size and overcurrent protection are adequate for the connected loads. The NEC specifies the maximum allowable load on branch circuits based on the circuit's ampacity. For example, a 15-amp branch circuit is typically limited to a maximum load of 1440 watts, while a 20-amp branch circuit is limited to 1920 watts. Consider future expansion when performing load calculations. It is advisable to include a buffer to accommodate future electrical needs, such as adding new appliances or equipment. This can prevent the need for costly upgrades in the future. Document all load calculations, including the assumptions, formulas, and demand factors used. This documentation is essential for permit applications and inspections. Accurate load calculations are critical for ensuring the safety and reliability of electrical systems. Incorrect calculations can lead to overloaded circuits, overheating, and potential fire hazards. It is important to consult with qualified electrical professionals and follow the NEC guidelines to ensure that load calculations are performed correctly. The NEC provides detailed requirements for calculating the service load of a dwelling unit. These requirements are found in Article 220 of the NEC. Firstly, determine the general lighting load, which is calculated based on the square footage of the dwelling unit. The NEC specifies a minimum lighting load of 3 volt-amps per square foot for dwelling units. Multiply the square footage of the dwelling unit by 3 volt-amps per square foot to determine the general lighting load. Secondly, calculate the small appliance branch circuit load. The NEC requires a minimum of 2 20-amp small appliance branch circuits for the kitchen and dining areas of a dwelling unit. Each small appliance branch circuit is rated at 1500 volt-amps. Therefore, the total small appliance branch circuit load is 3000 volt-amps. Thirdly, determine the laundry branch circuit load. The NEC requires at least one 20-amp laundry branch circuit for each dwelling unit. The laundry branch circuit is rated at 1500 volt-amps. Fourthly, calculate the appliance loads. Include the nameplate ratings of all fixed appliances, such as refrigerators, dishwashers, washing machines, and dryers. If an appliance is used continuously for 3 hours or more, multiply the load by 125%. Fifthly, determine the heating and air conditioning loads. Include the nameplate ratings of all heating and air conditioning equipment, such as air conditioners, heat pumps, and electric heaters. If the heating or air conditioning equipment is the largest load in a dwelling unit, multiply the load by 125%. Sixthly, apply demand factors. The NEC allows demand factors to be applied to the general lighting load, small appliance branch circuit load, and laundry branch circuit load. The demand factors vary depending on the size of the dwelling unit. For example, the first 3000 volt-amps of the general lighting load, small appliance branch circuit load, and laundry branch circuit load can be taken at 100%, while the remainder can be taken at 35%. After applying all applicable demand factors, sum the loads to determine the total service load. This total service load is used to determine the size of the service entrance conductors and overcurrent protection. The NEC provides tables for determining the ampacity of service entrance conductors based on the service load. The NEC also provides requirements for the size and type of overcurrent protection. Ensure that the service entrance conductors and overcurrent protection are sized appropriately for the service load. This will ensure that the electrical system is safe and reliable. When calculating the load for ranges and cooking appliances in a dwelling unit, the NEC provides specific guidelines to simplify the process. These guidelines are found in Table 220.55 of the NEC. The standard method for calculating the load for ranges and cooking appliances involves using the nameplate rating of the appliance and applying demand factors based on the number and rating of the appliances. The NEC provides a table that lists the demand factors for various combinations of ranges and cooking appliances. For example, if there is only one range in the dwelling unit, the demand factor is typically 8 kilowatts. If there are two ranges, the demand factor is typically 11 kilowatts. If there are three ranges, the demand factor is typically 14 kilowatts. These demand factors account for the fact that not all ranges and cooking appliances will be used simultaneously at their maximum capacity. The demand factors are applied to the total nameplate rating of the ranges and cooking appliances to determine the calculated load. This calculated load is then used to determine the size of the branch circuit and overcurrent protection. The NEC also provides an optional method for calculating the load for ranges and cooking appliances. This method is allowed in certain circumstances, such as when the ranges and cooking appliances are all of the same type and rating. Under the optional method, the load is calculated based on the nameplate rating of the largest range or cooking appliance. This method can simplify the load calculation process, but it may result in a higher calculated load than the standard method. When calculating the load for ranges and cooking appliances, it is important to follow the NEC guidelines carefully. This will ensure that the branch circuit and overcurrent protection are sized appropriately for the load. It is also important to consider any local codes or regulations that may apply. Some local codes may have additional requirements for calculating the load for ranges and cooking appliances. When calculating feeder and service loads for multi-family dwellings, the NEC provides specific guidelines to ensure that the electrical system is adequate for the building's needs. These guidelines are found in Article 220 of the NEC. The process involves several steps, including determining the load for each individual dwelling unit, applying demand factors to account for diversity in usage, and summing the loads to determine the total feeder or service load. Firstly, you must determine the load for each individual dwelling unit in the multi-family dwelling. This involves calculating the general lighting load, small appliance branch circuit load, laundry branch circuit load, appliance loads, and heating and air conditioning loads for each unit. The NEC provides specific requirements for calculating these loads. Secondly, apply demand factors to the loads. Demand factors account for the fact that not all dwelling units will be using their electrical systems at the same time. The NEC provides demand factors for various types of loads in multi-family dwellings. For example, demand factors can be applied to the general lighting load, small appliance branch circuit load, and laundry branch circuit load. The demand factors vary depending on the number of dwelling units in the building. Thirdly, sum the loads for all the dwelling units, taking into account the demand factors. This will give you the total feeder or service load for the multi-family dwelling. Once you have determined the total feeder or service load, you can select the appropriate size of conductors and overcurrent protection. The NEC provides tables for determining the ampacity of conductors and the size of overcurrent protection based on the load. Ensure that the conductors and overcurrent protection are sized appropriately for the load. In addition to the general requirements for calculating feeder and service loads, the NEC also provides specific requirements for certain types of loads in multi-family dwellings. For example, the NEC provides requirements for calculating the load for electric ranges and cooking appliances. It is important to follow the NEC guidelines carefully when calculating feeder and service loads for multi-family dwellings. This will ensure that the electrical system is adequate for the building's needs and that it is safe and reliable. Load calculations are essential for ensuring the safe and efficient operation of electrical systems in buildings. They determine the electrical demand of a building, helping to prevent overloads and potential hazards. The basic steps in performing a load calculation involve identifying all the loads that will be connected to the electrical system, applying demand factors to account for diversity in usage, and summing the loads to determine the total calculated load. To begin, identify all the loads that will be connected to the electrical system. These loads can include lighting, receptacles, appliances, heating, ventilation, and air conditioning, HVAC, and motors. Each load should be listed with its volt amps or watts rating. After identifying all the loads, apply demand factors to account for the fact that not all loads will be operating at their maximum capacity simultaneously. The NEC provides demand factors for various types of occupancies and loads. Demand factors are reduction percentages that are applied to the loads to reflect the expected diversity in usage. After applying all applicable demand factors, sum the remaining loads to determine the total calculated load. This total load is used to determine the required size of the electrical service, feeders, and branch circuits. It is important to follow the NEC guidelines carefully when performing load calculations. This will ensure that the electrical system is safe and reliable. It is also important to consider any local codes or regulations that may apply. Some local codes may have additional requirements for load calculations. When calculating the size of electrical services and feeders, several factors must be considered to ensure the safety and reliability of the electrical system. The electrical service is the main connection between the utility company's power grid and the building's electrical system, while feeders are the conductors that carry power from the service to various distribution points within the building. Firstly, the total calculated load is a primary factor in determining the size of the electrical service and feeders. The total calculated load is the sum of all the electrical loads in the building, taking into account demand factors. The service and feeders must be sized to handle the total calculated load without overloading. Secondly, conductor ampacity must be considered. The ampacity of a conductor is the maximum amount of current that it can safely carry. The NEC provides tables that list the ampacity of various types of conductors based on their size and insulation. The service and feeder conductors must be sized to have an ampacity that is equal to or greater than the total calculated load. Thirdly, overcurrent protection is required. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect the electrical system from overloads and short circuits. The service and feeder overcurrent protection devices must be sized to protect the conductors from overcurrent. The NEC provides requirements for the size and type of overcurrent protection devices. Fourthly, voltage drop must be taken into account. Voltage drop is the decrease in voltage that occurs as electricity flows through a conductor. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The service and feeder conductors must be sized to minimize voltage drop. The NEC provides guidelines for calculating voltage drop. Fifthly, future expansion must be considered. It is advisable to include a buffer in the size of the electrical service and feeders to accommodate future electrical needs. This can prevent the need for costly upgrades in the future. Sixthly, local codes and regulations must be followed. Some local codes may have additional requirements for the size of electrical services and feeders. It is important to check with the local building department to ensure that the electrical system complies with all applicable codes and regulations.